Today we're going to continue our conversation about nuclear decay. Remember that the word nuclear means nucleus and decay means to break down. Previously we have reviewed nuclear equations and watching a radioisotope break down with an alpha, beta, or gamma radiation. Today we're going to talk about a different way radioisotopes decay, and that is through its half-life. All radioisotopes decay at a certain rate, and that's what we call the half-life. This is the time it will take for half of a sample to decay. To give you an example, let's say we start with 100 grams of sample. If it goes through one half-life, we will take 100 grams and divide it by 2. So after one half-life, we will have 50 grams of substance left. If we go through another half-life, we will have 25 grams. If we go through 3 half-lives, we will have 12.5 grams. And if we go through 4 half-lives, we will have 6.25 grams. Notice how each time we go through a half-life, we divide our mass by 2. When you are completing a half-life problem, there are certain keywords and numbers to look for. For example, we have initial mass. Remember that mass is measured in grams, so these will be numbers that have the letter G or the word gram behind it. We are also looking for final mass. Again, with mass, we are looking for numbers that have grams or the letter G behind it. We're also looking for the time it takes for one half-life to occur. Since this is a unit of measurement for time, this could be in minutes, it could be in seconds, it can be in years, days, months, any unit of time. We're also going to look for the total amount of time it takes for the experiment to occur. Again, this unit of measurement can be seconds, it can be minutes, it can be days, years, months, whatever the question calls for. We are now going to practice a couple of half-life problems. For your first problem, we're going to pick out the important information. So we have, what is the half-life of a 100-gram sample of nitrogen-16 that decays to 12.5 grams in 21.6 seconds? So what is important about this? I'm going to circle all of my important numbers. Here I see 100 grams, so I'm going to circle that number. I see nitrogen-16. Even though it's important to know what element or radioisotope we are working with, nitrogen-16 is not important to do the math behind this half-life problem, so I'm going to ignore it. The next number I see is 12.5 grams, which is a mass, so I'm going to circle it. And then the last number I see is 21.6 seconds, another important number. This question is asking me to determine the half-life of the sample. So, I know that 100 grams is where I'm starting. This is my starting mass. I also know that 12.5 grams is my final mass because it's saying that it's decaying to the point where we only have 12.5 grams left. 21.6 seconds is my total time. This is telling me how long it is taking for the experiment to occur. So this is my total time. There are several different ways that you can solve a half-life problem. However, I don't want to use formulas. I'm going to kind of rationalize this problem. My personal favorite method for solving a half-life problem is to use the half-life tree. Now, when you use the half-life tree, you always start with your you always start with your initial mass at the top of the tree. So you're going to put your starting mass at the top. And then every time your sample goes through a half-life, we are going to break our starting mass in half. Half of the mass is decayed and turned into something different, so I put an X here. And then I will have a number, a value here. If my sample goes through another half-life, I'm going to split it in two again. Half of my product has changed into something new, it's decayed, and then I'll have a mass over here. I will continue to do that until I reach my final amount. Okay, so let's practice doing that with our numbers here. I start with 100 grams, so I'm going to put 100 grams at the top of my tree. Okay, now in this problem it does not tell me how many half-lives I'm going to go through. However, it does tell me that I end with 12.5 grams. So I'm going to split my sample in half until I get to 12.5 grams, meaning I'm going to take this number and divide it by 2 several times until I get to 12.5. So I have 100 grams. When I divide it by 2, half of my sample is decayed and turned into something different, and the other half of my sample is still nitrogen-16, so I have 50 grams left. Remember, I'm trying to get a 12.5, not quite there yet, so I'm going to take this mass and I'm going to divide it by 2 again. Half of it is dead, the other half I have 25 grams remaining. Going to split it in half again. Half of it is dead, it's a different radioisotope, and then my other half is still good. So I have 12.5 grams here. I have reached my final amount, so I can stop dividing by 2. We did this in order to find out how many half-lives have occurred. 3 half-lives have occurred here. That is not the answer to my question. My question is asking me how long is 1 half-life. Well, if I look at this whole experiment, my total time is 21.6 seconds. That's how long it took for this experiment to occur. I am looking to see how long it takes for 1 half-life to occur. So, if I take 21.6 and divide it by 3, because that's how many half-lives have passed, I will get my half-life time, which is 7.2, that should be 7.2 seconds. One way that you can check your work is you can go through your half-life tree and say, this half-life took 7.2 seconds. This half-life took 7.2 seconds. And this half-life took 7.2 seconds. If I add all of these half-lives together, I should get my total time, which is 21.6 seconds. And I do. So this is going to be the answer to this question, 7.2 seconds. Let's try another one. Problem number 2. All isotopes of technetium are radioactive, but they have widely varying half-lives. If an 800 gram sample of technetium decays to 100 grams of technetium in 639,000 years, what is the half-life? The first thing I'm going to do is I'm going to go through here and pick out the important numbers. So here I see 100 grams. I'm going to circle that. Here I see 100 grams. I'm going to circle that. And here I see 639,000 years. Now remember, technetium is important, but it's not important to our question, so I'm going to ignore those numbers. Okay, so 800 grams is telling me where I'm starting, so that's my starting mass. 100 grams tells me my final mass, is where I'm going to end. And 639,000 years is telling me the total time. I know it's telling me the total time because it's saying that all this is happening in 639 years. And the question is asking, what is the half-life? So we're going to set this problem up exactly like we did the last problem. I'm going to put 800 at the top of my tree. I don't know right now how many half-lives or how many times I'm going to divide by 2, so I'm just going to continue to divide by 2 until I get to 100. So 800 divided by 2 is 400. So 400 grams of this sample is still good, while the other half has changed into something different. I'm going to take 400 and divide it by 2 to get 200. That's supposed to be a 2. And the other half of it has changed into something different. Alright, I'm almost there. I'm going to take 200 and divide it by 2. And I get 100 grams, which is my final sample. So I know I can stop here. I went through 1, 2, 3 half-lives. However, that is not the answer to the question. This question is asking how long does it take for 1 half-life to occur. Well, we know that it took all 3 of these half-lives 639,000 years. Okay? So how long does it take for 1 half-life to occur? In order to figure this out, we're going to take 639,000 and we are going to divide it by our number of half-lives, which is 3. When you take 639,000 years and divide it by 3, you get 213,000 years. That's how long it took for one of these splits to occur. Do not forget about your units of measurement when you are writing your answer. So there is our answer. We have time for one more. I want to do a little bit of a different question this time. Okay, I'm actually going to change this number here to say 13. Okay. Alrighty, so we have a 208 gram sample that decays to 13 grams within 60 hours. What is the half-life? Okay, so here I have 208 grams. Actually, this is exactly like this question we just did. So I will make another video to show you how to do a different question. And here we have 60 hours. Okay, 208 grams is where I start. 13 is the end point, my final. And 60 hours is my total time. I am looking for the half-life. So I'm going to set this up and I'm going to build my tree. So as you can see here, I've built my tree and I start with 208 grams and I divide it by 2 all the way down the tree. I divided by 2 until I got to 13 grams. In this particular question, I went through 4 half-lives. Okay, this is 4 half-lives. That is not the answer to my question. Okay, my question is saying all of this happened in 60 hours. And I want to know how long it takes for 1 half-life. So I'm going to do 60 divided by 4, which will give me 15. I have 15 hours for 1 half-life. So that is the answer to my question. Alright, this is the last question that we're going to do together. I went ahead and set it up because I'm running short on time. I've circled my important questions or my important numbers. This one's a little bit different because now this is telling me that the half-life is 8.10 days. I had 500 grams to start with and now I have 6.25 grams. So I've already built my tree and now I'm looking for a total time. Well, I know that 1 half-life happens every 8.10 days. So this half-life took 8.10 days. This half-life took 8.10 days. And this half-life took 8.10 days. If I'm looking for a total time, I'm going to add these numbers together. When I add 8.10 plus 8.10 plus 8.10, I'm going to get 24.3 days. That is how I figure out my total time. Practice doing some on your own, and good luck!